Hi everyone, I am Dr. R. Bhaskaran, Associate Professor, Department of Biotechnology, Kamaraj College, Indian Technology, Virudhunagar. Today we are going to see about the heat transfer. In the heat transfer, we are going to see about the introduction to heat transfer, basic concepts and modes of heat transfer, and then governing laws for the heat transfer. First one is the what is meant by heat. Heat is nothing but that is movement of thermal energy. Generally, the heat should be transferred from the high temperature to the low temperature. For example, we can take the hot objects in the cooler room. What happen? The objects also cool to the room temperature. In the case of cold object in the warmer room, what happen? The objects of the heat should be increased to the hotter. So, similar way, the movement of the thermal energy move from the high temperature to the low temperature. Types generally the conduction has to be takes place into the two type. First one is the steady state heat conduction, another one is the unsteady state heat conduction. What is steady state heat conduction means? It is the temperature at particular point does not vary with the time. It is called the steady state heat conduction. In the case of unsteady state heat conduction, it is the temperature at particular point it can be vary with respect to temperature. It is called the unsteady state heat conduction. Next one is the application of heat transfer. So, where it is used? Mainly most of the industries they can use the heat transfer. First one is the transformer and the integrator circuit. In mechanical engineering, it is mainly used for the refrigeration, boiler and then heat exchanger for storing purpose as well as for the transfer of the energy. Next one is the heat versus temperature. What is the difference between the heat? Then what is the difference between temperature and the heat? So, first one is the heat is nothing but that is actual energy. How much amount of energy should be transferred? It is called as the heat. Whereas in the case of temperature, it is measure of the average kinetic energy of the particle. How much amount of energy should be transferred? It is called as the temperature. Next one is the difference between the thermodynamic and the heat transfer. For first one is the thermodynamics. What is thermodynamics? The thermodynamics it is mainly deals with the amount of heat transfer. That is how much amount of heat should be transferred from the high temperature to the low temperature. It is called as the thermodynamics. Whereas in the case of heat transfer, it is the rate of heat transfer. The thermodynamics it should be occur only in the equilibrium state conditions, whereas the heat transfer occur only in the non-equilibrium state condition. Thermodynamics there is no temperature gradient is occur, whereas in the case of heat transfer the temperature gradient is occur. These are three major things for the difference between the thermodynamics and the heat transfer. Next one is the modes of heat transfer. According to the physical mechanism and the governing law associated, the heat transfer has takes place into three ways. First one is the conduction, convection and the radiation. What is conduction? So, conduction it is the conduction is a heat transfer flowing from heat energy from the high temperature object to the low temperature object. Generally we know that the conduction the heat should be transferred from the high temperature to low temperature. It is mainly occur in the solid objects. So, in the case of solids, there are two mechanisms the heat should be transferred. First one is the lattice vibration, second is the free electron movements. In the case of conduction, there is no actual movement of the molecule has to be takes place. For example, metal is a conductor where wood is a insulator. So, metal it conduct the heat whereas the wood does not conduct the heat. It is some example for the conduction. Next one is the convection. In the case of convection takes place when the heated molecules move from one place to another place taking the heat with them. It is called as the convection. In the case of convection, there are two types of convection, natural convection and the forced convection. In the case of natural convection, it is mainly occur due to the natural differences. For example, the difference in density. So, the convection has to be occur. Whereas, in the case of forced convection, the heat is transferred from one place to another place through the external forces. For example, fan, pump like that. So, that in the case of convection, it is mainly occur in the gases and the liquids. In the case of convection, the heat is transferred occur in the fluid medium. heat is transferred by actual movement of the molecule, whereas in the case of conduction there is no actual movement of the molecule, whereas the heat transfer occur to the lattice movement, whereas in the case of convection the heat is transferred by the actual movement of the molecules. So, the energy transfer between the solid, from the solid it transferred to the adjacent layer of the liquid or gases. So, the convection mainly depends upon the properties of the fluids, not properties of the solids. Next one is the radiation. In the case of radiation, the heat transfer should be occurred by the electromagnetic phase. For example, ultraviolet radiation, sunlight or artificial light. We have to create the artificial light. From this artificial light, the heat should be transferred from one place to another place. That is called as the radiation. So, next topic is the governing law of radiation. So, the conduction, convection, radiation, the three are mainly occur due to the basic of the governing law. What are the governing law? The governing law has to be vary, depends upon their mode of heat transfer. For the conduction, it is a Fourier law of heat conduction. In the case of convection, it is a Newton's law of cooling, whereas in the case of radiation, it is the Boltzmann law. That is called the assumptions. What are the assumptions has to be made for the governing law? First assumption is the heat transfer takes place under steady state condition. What is steady state condition? That is the temperature at a particular point does not vary with respect to time. The second one is the heat flow is the unidirectional. Third one, there is no internal heat generation, and then fourth one, the bounding surfaces are isothermal. Then last one is the middle is the homogeneous isotrope, that is thermal conductivity should be same. So, these are the assumptions has to be made for governing laws. So, governing law, first one is the conduction. It is the Fourier law of heat conduction. In the case of Fourier law of heat conduction, that is Q by A. What is Q? It is rate of heat transfer and A is the area. So, the rate of heat transfer per unit area is directly proportional to the temperature gradient dt by dx. dt is the temperature difference, dx is the thickness. So, the rate of heat flow per unit area through the homogeneous solid is directly proportional to the temperature gradient. It is called as the Fourier law of heat conduction. So, it is written as Q is equal to minus Ka into dt by dx. Next one is the Newton's law of cooling. In the case of Newton's law of cooling, the heat transfer given by Newton's law. So, its rate of heat flow per unit area is directly proportional to the temperature difference between the system and the surrounding, that is the Q by A. Q is equal to rate of heat transfer, A is equal to area is directly proportional to the difference in temperature Ts minus T infinitive, whereas Ts is the solid surfaces, whereas T infinitive is the surrounding. So, the difference between the systems and the surrounding is directly proportional to the Q by A. So, that the rate of heat transfer Q is equal to H into A, whereas we can remove the proportionality, we can add the equal, that is H is the heat transfer coefficient, A is the area, then Ts minus of T infinitive. Then the heat transfer coefficient, it is mainly depends upon thermodynamic properties such as density, viscosity and specific heat and thermal conductivity of the fluids. And second one is the geometry of the surfaces, then third one is the nature of the fluid, whether the fluid is laminar or turbulent. In the case of laminar flow, Reynolds number is less than 2000, where turbulent flow Reynolds number is greater than 2000, and then thermal conditions. Next one is the Stefan Boltzmann's law constant. In the case of Stefan Boltzmann's law, the maximum rate of heat per unit area by the surfaces is directly proportional to the fourth power of the absolute temperature. It is the governing law for the radiation. So, that is Q by A. Q is equal to rate of heat transfer, A is equal to area is directly proportional to the Ts power, for Ts is the surface temperature. So, it can be written as Q is equal to sigma into As into Ts power 4, where the sigma is called the Stefan Boltzmann's law constant. So, the rate of heat transfer Q is equal to As and the Ts power 4. It is also written as overall heat transfer coefficient for the radiation, also written as Q is equal to epsilon, where epsilon is called as the emissivity sigma into As into Ts power 4 minus Ts surrounding power 4. So, the surface emissivity is the epsilon naught, and then surface area is equal to As, and then T is the complete surfaces, it should be enclosed by the black body, T surrounding is surrounded by the gas, and next one is the net rate of radiation. So, thank you.